Hi folks, we're going to take a look at number 15 from page 498. So a lot of things going on here. So they give us these two lines, and they in fact tell us that they intersect at a point, so we should be looking for that. So part A is to just determine that point of intersection, and then part B says determine the vector equation for a line that's perpendicular to both lines and passes through A. Okay, so we'll talk about B in a second. Let's solve part A first. Okay, so here I notice, again, something quite nice, because I notice the x component of the second direction vector is equal to 0. Okay, so that means based on the first equation, the second equation, x always has to be equal to 4. Okay, so that means whatever we have from the first equation of that line, it's going to have to equal to 4. So we've got -1 plus 5s is going to have to equal 4, so 5s is equal to 5, and so s is equal to 1. Okay, and so now we can calculate the t value using one of the other equations. Okay, so here, taking a look, looks like y looks a little nicer, so I'll work with y here. So let's take the first equation. We have 3 minus 2s. Okay, because it's -2 there, so 3 minus 2. Now we know s is equal to 1, so I'll replace that in right away. And the y value here is going to be -1 plus 2t. And so here we can solve for t. So we've got 3 minus 2 is 1, plus 1 is 2, divided by 2 is 1. So s and t both equal to 1, so easy solutions there. Okay. Now, just to be sure, even though they did tell us that it does intersect at a point, let's be sure that these are indeed the ones that that do work. And so let's check the z components. So we've got z, I'll call it z1. From the first one is 2 plus 10s. So that's 2 plus 10 times s, which is 1. So that's 12. And z2 from the second equation, 1 plus 11t, so 1 plus 11 times t, which is equal to 1, which is also equal to 12. Okay, so we have confirmed that there is indeed a point of intersection. Okay, so let's just find the x and y values. So we know x is equal to 4, so we don't have to calculate that. Okay, so let's calculate the y value now. So y, here, we can use it from here. -1 plus 2 times t, and t is equal to 1, so -1 plus 2 is just 1. Okay, so that means that our point of intersection is equal to 4, 1, 12. Okay, so now let's use this to hopefully solve part B. So part B says determine the vector equation for the line that is perpendicular to the two given lines and passes through A. Okay, so first of all, I'm looking for the equation of a line. Okay, so I know that I need a point and a direction vector. So I already have my point, which is A, and that point is what we found, 4, 1, 12. Okay, and now I need a direction vector. And this, hopefully, you're starting to get the idea that when I need something that's perpendicular to two other things, I'm probably going to use the cross product. Now, in particular, it has to be perpendicular to these two lines. So here's one line, there's another line. So I need a vector that's perpendicular to both of these lines. Okay, so that's going to be my direction vector for the line that I'm looking for. And of course, what I can do is take the direction vectors of both of those lines, take the cross product to get that vector that's perpendicular to both. Okay, so that's how we're going to proceed. So let's start with the first vector there. We've got 5, -2, 10. Add another 5 there. And we've got 0 to 11. So 0 to 11. Put another 0 there. So the cross product here will give us -22 minus 20. So that's -42. Here we have 10 times 0. Okay. So minus 55, so minus -55, and so here we have 10 minus 0, so that's just going to be 10. Okay, so this here is going to be our direction vector, and so now we can write, this is part B by the way, so now we can write the equation of the line. Okay, so it's just going to be our given point, 4, 1, 12, plus, I guess we've already used S and T, so let's use, I guess, U. Okay, plus U times our direction vector. So here you could, I guess, multiply by -1, but no big deal. I'll use -42, -55, and 10. Okay, and U is any real number. Okay, so just to recap here, to find the point of intersection, keep an eye out for any components of direction vectors that are equal to 0. Helps simplify the algebra. And then once I found the point, I could find a vector perpendicular to both those lines using the cross product to help me determine the